moments of forces that we started last time. So we have seen that the moment of a force is a vector that is perpendicular to the plane formed by the force and the projected distance from the force to the axis. And in magnitude, it's given by the magnitude of the force times the projected distance. Now, in order to find the direction of a force, we can use the right-hand
Walter,
rule.
are you talking?
Yes. Do you hear me now? Yes, I am talking.
And I hear you, doctor.
Okay. So the direction of the moment can be found by applying the right-hand rule. If you look at the following figure here, if you put your four fingers along F and the face of your hand is looking towards O, then your thumb will point out upward. Okay? So you can view here the view from a profile view and a top view. Okay? And you can see that, for example, here in the top view, the moment is in the counterclockwise direction. By just doing the right-hand rule, you can find this. And also here, you can see the vector moment. Here you cannot see the vector moment because it's perpendicular to the board, okay, to the screen. It's perpendicular to the screen. While here you can see that it is pointing upward, okay? Now, in 2D problem, the moment can be defined just by indicating whether the rotation is clockwise or counterclockwise. No need to, because as we said, if you have motion in XY plane, the moment will be along Z. Since all forces are along XY, so they cannot produce moments about X and Y, they can only produce moment about Z. So as you can see here, for example, this is plane XY. This is X, let's say, and this is Y, and this is Z, okay? Since force F is in plane XY, it will only produce a moment about Z. This is why in 2D you don't need to say it's directly along Z or plus Z or minus Z. So you can define the sense in another way. You can just say if it is clockwise or counterclockwise. Now, how to find the resultant moment for several forces in one plane? So if you have a system of forces all in XY plane, then you will be sure that the moments of these forces about a point O will always be directed along the axis. And as we said, it can be along plus K or minus K. So in this case, what we do is we define a positive convention for the moment, clockwise or counterclockwise. And as you can see here, the positive convention, you mention it when you write the equation. So here, when you write the resultant moment is equal to the summation of all moments, you will put this symbol, okay? This symbol will tell you what is the positive direction you will consider. If you consider that positive moment is in the counterclockwise direction, you put this arrow. And if you want to have the opposite convention, you do this, you put like this. You put an arrow like this, okay? And you say that this is positive. In this case, you will count any clockwise moment as positive and any counterclockwise moment as negative, okay? And in this case, to find the total moment, what you should do, you should add the algebraic value of moments, okay? So, for example here, let us do an example to see how to do it. So determine moments of about points A, B, C, and D for this force F. Okay, so if you look at this figure, you want to find the moment of F about different points. Let us start by A. To find the moment about A, you should multiply by the following distance, which is 2.5. Okay, because this is the perpendicular distance from F to A. This is the perpendicular distance. Okay, and to know the direction, you use the right hand rule. And you can simply also, instead of the right hand rule, with your, if you look at your figure, it's clear that F is rotating about A in this direction, so it's in the clockwise direction. This is why here, when you find MA, you say it's the force 800 times the distance to A, which is 2.5, and it is in the, you put the arrow here in the clockwise direction. Now, to find the moment about MB, about point B, you should find the distance from B to the force. The distance from B to the force is the following. This is the distance that is perpendicular to F. It's equal to 1.5. So you say that the moment about B is 800 times 1.5. And also for the direction, as you can see, it's rotating in the clockwise direction. So you can put a clockwise arrow here. Now, for point C, what is the moment of F about point C? The force F, as you can see here, is passing by C, so it cannot produce a moment about C. So moment of F about C will be 0. Now, if we take the moment of F about point D, the distance from F to D, the perpendicular distance is 0.5, and it's rotating now in the counterclockwise direction. Okay, so this is the direction of rotation, it's counterclockwise. Therefore here, if we want to put the arrow, so it is in the opposite direction, like this. Now, in the second example, we want to determine the resultant moment. We want to determine the resultant moment of this system of forces about point A. Okay? To do this, all we have to do is to sum moments of all forces about this point. Okay? So let us look at our figure. We have different forces. We will start to find the moment of each force about O, and then we do the addition. Now, you should choose a positive convention to follow. So let us say we will choose the positive convention as counterclockwise. So any moment in the counterclockwise direction will be counted as positive, and any moment in the clockwise direction will be counted as negative. So let us look at the figure here. First, for the 50 Newton force. To find the moment of 50 Newton force about O, the first step, as we said, we draw the perpendicular from O to the force. The distance between the two is 2. And for the moment, look, how the 50 Newton force is rotating about O is rotating in the clockwise direction. And since I choose the counterclockwise as positive, then for this force, the moment will be minus 50 times 2. Now, for the force of 60 Newton, the force of 60 Newton is passing by O, so it cannot produce any moment about O, so it's plus 0. Now, I have here two other forces. I will start by the 20 Newton force. For the 20 Newton force, it's producing a moment in the counterclockwise direction, so it has a positive moment. Now, to find the magnitude of this moment, we do the projection from O towards the line of action of the force. This is the line of action of the force here. This is the line of action. And if I do the projection from O to the line of action, this is the distance I should multiply with. So this distance here is equal to this one. And this distance is simply, if I look at my figure, it's 3 sine 30. So the distance here is 3 sine 30. So to find the moment of 20 Newton, it's plus 20 times 3 sine 30. Now I still have only one force, this one, okay? So also to find the moment of this force, first I can look at the direction. The direction of the moment is in the clockwise direction, so it's a negative moment. And now to find the value of this moment, I do the projection line, the projection from O towards the line of action of the force. This will be my distance, okay? This is my total distance. This distance can be calculated by dividing it into two parts, since it's equal to this length here, which is 4 meters, plus this part, and this part here is equal to 3 cosine 30, okay? So here's in the triangle here, this is 3 cosine 30. So in total, the distance will be 4 plus 3 cosine 30. And I multiply it by 40. And I don't forget to put a minus since it's rotating in the clockwise direction. And now when I do the summation of all my moments, I will obtain the result. I will obtain a negative result. This means that my resultant moment is clockwise. So because since the counterclockwise was my convention, if I obtain negative result, then my moment is in the clockwise direction. How do we know the direction of the 20 Newton force? You mean for the moment, Christina?
Yes, in this example.
Okay, look, for the 20 Newton force, you use the right hand rule, okay? Or you do this, you say this force, how it's tending to rotate about O like this, in the counterclockwise direction. Or you can use the right hand rule, put your 4 fingers along the 20 Newton force, and the face of your hand looking towards O, okay? So, your 4 fingers along the 20 Newton, and your hand and the face of your hand looking at O. How, if you try to rotate your hand, it will rotate in this direction, in the counterclockwise direction. Okay? If you want to see it better, look, if you displace a force on its line of action, it will not, it will produce the same moment about any point. So if you put this force here, okay, maybe you can see it better here. If you put this force here, how it's trying to rotate about O? It's rotating about O in the counterclockwise direction. Okay?
Doctor,
Yes.
to find the distance for the 20 Newton, what do we do?
Okay, when you want to find the distance, if you want to find moment of 20 Newton about O, what is the distance? The distance is between O and the line of action of the force. This is the line of action of your 20 Newton force. So what you do is you do the projection from O to this line, the perpendicular, okay? This is your distance D, which is perpendicular from O to the line of action of the force. How to find D? D is equal to the length here. They are equal, okay, because you have parallel lines. And D here is equal to 3 sine 30, okay?
Okay.
Now, on the other hand, for the 40 Newton force, okay, what you do is, this is the line of action of this force, it's the vertical. So now, what is the distance? You draw the perpendicular from O to this line. The total distance here is equal to 4 plus 3 cosine 30, okay? So always you draw the perpendicular from the point to the line of action of the force. Any other question on this?
Yes, دكتور أول فورس اللي هي 50 نيوتن she is
Yes.
passing through O يعني ما بتعمل
No, 50 Newton is not passing through all. 60 Newton is passing through all. 60 Newton is passing through all. But the 50 Newton force, okay, is
بس
passing
هي
by the
parallel
axis.
على الواي.
Look, 50 Newton is passing by x-axis, but not by O. 50 Newton force is not producing a moment about x, of course, and not about y. It's producing a moment about z, and z-axis is passing by point O, okay? So here, when we say sum of moment about O, we mean sum of moment about z-axis passing by O, okay?
okay.
The distance from O to the force, to the 50 Newton force, you do the perpendicular from O to this force, it's 2 meters, okay?
As for the direction in X and Y plane ما عم بعرف إذا هي clockwise أو can you repeat please?
Okay, look, for the direction, I will prepare a video for you because you will not understand it like this. Okay, you will use the right hand rule. I will do a video and send it to the group to see how to find clockwise and counterclockwise direction. So, but even if you don't use the right hand rule, if you try to do some, try to imagine how this force is tending to rotate the bar. Look, if I'm putting a force on the bar, how it will tend to rotate it? Not in this way.
Yes.
Okay, so the moment of 50 is clockwise. Now, for the 20 Newton force, it's trying to pull it into this side. So 20 Newton force is trying to rotate it in the counterclockwise direction. While the 40 Newton force is trying to rotate it in the clockwise direction. So or you use this method or you use the right hand rule. For the right hand rule, I will send you a video for it, okay?
Okay, بأول example كيف جبنا ال F
Yeah.
direction تبعها؟
The direction of the moment, you mean?
Yes.
It's the same
هي
procedure.
clockwise.
It's the same procedure. About A and B, your force F is tending to rotate the structure in which direction? Like this. So
Right.
you can imagine that if I apply F about this part, I want to find moment about A and B, it will try to produce about A and B a moment in this direction, so it's clockwise. However, with respect to point D, it's trying to rotate the bar about D in the counterclockwise direction. Okay, so you should always look what is your point of interest. If it's D, F is trying to rotate the structure about D in this way. If it's A and B, it's trying to rotate in this way. Okay?
Okay. Thank you.
Now, another example. We want to find in this figure the moment of the 100 lb force about point O. This is the first step. So as we said, what is the technique to find the moment? First, we can draw the line of the force. This is the line of action of the force. Okay? And we want to find the moment of this force about O. So we draw the perpendicular from O to the line of action of the force. This will be the projected distance D. We can say now that the moment in magnitude is equal to, the magnitude of the moment is F times D. And what is D? D is this distance. How you calculate this distance here? You have, this is 24, and this angle is 60. So D is 24 cosine 60, okay? You found the magnitude of your moment. Now, who will tell me how will be the direction of this moment? Clockwise or counterclockwise?
Clockwise.
Clockwise, very good.
Clockwise.
Because it's tending to rotate the bar about O in this direction, in the clockwise direction. So all you have to do is to put an arrow, just an arrow here, in the clockwise direction. Now, the next question, find the magnitude of a horizontal force applied at A, which will create the same moment about point O. So we want to find the moment of a horizontal force. What is the magnitude of a horizontal force creating the same moment about O? So I don't know what is FH, but I know that this horizontal force should create the same moment of the vertical force about O. Okay? First, can you tell me why I choose this direction and not the opposite one? Why I choose to put FH towards the right, not to the left? Because first
so
I
that
want
it's the same
yes,
sign.
very good, because it's the same direction of moment. So because the vertical force is producing a clockwise moment, I also want the horizontal force to produce a clockwise moment. This is why it should be towards the right. Because if I put it towards the left, it will tend to rotate the bar about O in the counterclockwise direction. So first, I am sure that FH should be to the right. Now, to find the magnitude of FH, I will write the condition. The condition is that the moment of FH about point O should be equal to F times D, okay? The previous moment I already found. And if I calculate the previous moment, it's equal to 120, okay? Now, what is the moment of FH about O? I should multiply by which distance? So this moment is equal to FH times which distance? I will call it D1, and I will put it on this figure. What is D1? D1 is the projection from O to the line of action of F horizontal. This is the line of action of F horizontal. If I project from O towards this line, okay, this distance of projection is equal to what? Is equal to this distance here. It's equal to 24 sine 60. So this is 24 sine 60. So now I can write that, I can deduce that FH is equal to 120 over D1, and D1 is, I replace D1 by 24 sine 60. Okay, so in this way, I have found what is the horizontal force required to produce the same moment about. Any question on this? Now, the second step, find the smallest force applied at A, which will create the same moment about O. Okay, who will tell me what should we do here? We want to find what is the smallest force that can be applied at A in order to produce the same moment about. Any idea?
Should the force be perpendicular to the line
Very
that's
good.
always on?
Very good. Yeah. Why? Because if the force is perpendicular to arm OA, then the projected distance will be maximum. Okay? Because look, as you can see, always we do the projection from O to the line of action of F, and this projection is smaller than 24. So the highest possible projection from O towards a line passing by A will be 24. Okay? In order to have the projection from O to the force 24, the force should be perpendicular to OA. Because once the force is perpendicular, the projected distance will be equal to the maximum value, which is 24. So here, this is the minimum possible force I can have. Because if I choose this direction of the force, what will be the projection? It will be maximum. My projection distance will be maximized. It will be equal to 24. And then I can say that this force, the minimum force F minimum, to calculate it, I say that the moment of F minimum is F minimum times 24 is equal to the moment, which is 120. So I find that F minimum is 120 over 24. And why I selected a downward force? Because I want a clockwise moment. So F minimum should be in the downward to produce moment in the clockwise direction. Okay? Now, the last question, find the distance from O of a 240 lb vertical force that must act to create the same moment about O. So the question now is, if I want to put a force of 240 lb that is vertical on my arm OA, at which location should I put it to produce the same moment of F? So the question is, this is a 240 lb force that is vertical. I have a 240 lb force. I want to know what should be its point of application. So what should be this distance? Let's call it D2. What should be D2 in order to produce the same moment about it? Can you give me in a fast way the answer? Just by
Doctor,
looking at the numbers. What should be
can't
D2?
we equate the numbers?
Yes. Why?
The
Because
correct
we will say that to produce the same moment, okay? You have the moment of F, which is 100 lb, is 100 times 24 cosine 60. We already did it in the previous, in the first question. Now for the 244, what is the moment? It's 240 times which distance now? Times d2 times cosine 60. As you can see, cosine 60 will be simplified. So I can say that d2 is equal to 120 over sorry, you have d2 is equal to 2400 over 240, which is equal to 10. Okay, why I can expect this result? Because you have the distance and the force are inversely proportional. Okay, so when my force was equal to 100, the distance was 24. So when the force will be equal to 24, the distance will be equal to 10, because I multiplied my force by 2.4. So I should divide my distance by 2.4, since the force and the distance are inversely proportional for the same moment. Because you know the moment is what? Moment after simplifying cosine 60, okay, you have that F times D is a constant. F times D is equal to a constant. So the force and D will be inversely proportional. So if I multiply F by 2.4, distance D will be divided by 2.4. This is why if I look at my numbers, I can directly say that D2 is 10, because F times 2.4 is 240, and 24 divided by 2.4 is 10. And this can be easily shown by the calculation. Okay? Any question on this? Okay, so let us continue. A very important application of vectors in moment is the cross product. Okay, and you will see why we will use it a lot in finding moment of forces. So for this reason, we will introduce the vectorial product. Okay, so the cross product of vectors A and B is written as A, this is vectorial symbol, okay, A vectorial B, which is defined as vector C is equal to A vectorial B. So the first difference between dot product and cross product is that the dot product will give me a number, while the cross product will give me a vector. Okay. Now, what is whenever I have a vector, I should define its magnitude and I should define its direction and sense. Okay. First, for the magnitude, if I have A vectorial B, the magnitude of vector C will be the magnitude of A times the magnitude of B times sine the angle between them. So if I look at the figure here, in this figure, you have two vectors, A and B. Okay? If you do the vectorial product, you will get a third vector of magnitude that is equal to magnitude of the first vector times magnitude of the second vector times sine of the angle in between. Now concerning the direction, okay, concerning the direction, you use the right hand rule, and here we show you here how to apply. In order, the right-hand rule will give you the direction and sense of vector C. How to do it? First, you take your right hand, okay? You put your 4 fingers along the first vector because you want to do A vectorial B. So first you put your 4 fingers along the first vector A, and you rotate your fingers towards vector B. Once you do this, your thumb will point upward. Try to do it, okay? Put your 4 fingers along A and turn your 4 fingers towards B. Your thumb will point upward. So this is the direction and sense of, the direction is vertical here and the sense is upward, okay? So the right hand rule will give you the direction of C, and it is clear here that vector C is perpendicular to the plane formed by AB. So always when you do A vectorial B, your resultant vector C will be perpendicular to the plane formed by A and B. So here if A and B constitute the horizontal plane, then C will be along the vertical. This is why we can write vector C as AB sine theta, which is the magnitude, times unit vector of C, where the unit vector is directed along the perpendicular to the plane formed by vectors A and B. Now, what are the main laws of operation for a vectorial product or cross product? First, it's not commutative. So if I do P vectorial Q, it's different than Q vectorial P. Why? Because P vectorial Q will give me the opposite of Q vectorial P. If you take a look at this figure, you will know directly why. First, the magnitude will be the same because AB sine theta is the same. But look, if I do B vectorial A, then I should put first my 4 fingers along B and rotate towards A. So my direction of rotation will be opposite. So if you use the right hand rule and you put first your 4 fingers along B and you rotate towards A, your thumb will be directed downward in this case. So B vectorial A will give you an opposite vector of A vectorial B. Okay? Now, another characteristic, if I multiply the vectorial product by a scalar, I can take the scalar with any of the 2 vectors. So for example, if I have 2 times P vectorial Q, I can say that it's equal to 2P vectorial Q or P vectorial 2Q, because for the number you can take it into factors, okay? So this is another characteristic. A third characteristic is that if I have P vectorial Q plus S and I want to do the development, it's like in numbers. So I do P vectorial Q plus P vectorial S. Now, I should pay attention a lot for the order in cross products. So if I have P vectorial Q vectorial S, I should know which 2 vectors to start with. And if I want to have P vectorial Q times vectorial S, I should first find this term. So I should always look at the brackets, okay? If I have P vectorial Q into brackets vectorial S, I should first start by P vectorial Q, then do vectorial S. So it's not like numbers, okay? So P here, if I do Q vectorial S, then I do P vectorial the result, I will obtain a different result. So it's in this application, it's different than numbers, because in numbers, if you do, for example, 2 times 3 times 4, it's equal to 4 times 3 times 2. But in vectorial product, no. If I change the order, then I will obtain a different result. So if I do Q vectorial S first, then I do P vectorial the result, it will not give me the same result of P vectorial Q first, then vectorial S. So always, if you have brackets, you should follow the brackets. You start by doing this term, and you do vectorial ask. Okay. Now,
Doctor, is ما في brackets.
إذا ما في brackets حيكون في brackets. Okay. إذا ما في brackets, you start by the first two vector and you follow the order. If you don't have brackets, you start P vectorial Q, then you do vectorial S. But in general, you will have brackets. Okay.
Okay.
Now, let us go back to our frame, X, Y, Z. If you remember, in previous chapter, we introduced the right-handed coordinate system X, Y, Z. And I told you it will be of high importance to have a right-handed coordinate system when we want to apply vectorial product. Let us see why, okay? So if I have here an X, Y, Z frame, and I can verify that it follows the right-hand rule. I posted for you for this video on a YouTube link for a video, so you can see how to apply the right-hand rule to verify that my system is a right-handed coordinate. So let us do it here. First, you put your 4 fingers along X and you rotate towards Y. When you do this, your thumb will act along positive Z axis. So here, this is a right-handed system, since Z is pointing along my thumb. On the other hand, if Z was downward, I cannot say that it's a right-handed coordinate system because it will not follow the right hand. Okay. Now, why I should put a right-hand coordinate system? To be able to apply the following laws. Okay. So if I have a right-handed system, I can apply all of the following relation, and we will learn how to remember them in a simple way. First, if you do I vectorial j, how to find this vector? First, yes.
My connection lag. Can you just repeat what you said about the slide?
Sorry, I cannot hear you. Okay, look, the time is nearly over, and we don't have a lot of time so the session will end in 2 minutes. So we will stop here for today, okay? And we continue this chapter on Monday, okay?
Thank you, Doctor.
Welcome.
Okay, thank you.
Bye.
Thank you, Doctor.